we've got Buzz Powell on the line, who has been involved in asphalt research a majority of his life. What they're doing at MCAT is pretty incredible. If you have not been there and you are down near Auburn, it's an awesome sight to see. They've got a great testing facility there, and I'll let him fill everyone in on it. And with that, I will turn it over to Buzz.
Well, good morning, everybody. Can y'all hear me okay?
Yep. I can hear you great. Thanks, Buzz.
Excellent, excellent. Well, I appreciate the opportunity to visit with y'all this morning and kind of give you an overview of my take on asphalt innovations. Those of you who know me know that the reason why I have such a rewarding experience here at the test track is because I was with Alabama DOT for 12 years, and then I was in the private sector for a few years, and now I've been at NCAT for over 20 years. And I get to do really innovative things and kind of evaluate emerging technologies on the track, because I'm essentially my own prime contractor every 3 years when we build, and then when we do periodic maintenance. And I kind of instinctively change hats from a specifier and enforcer to a contractor, and I'm kind of constantly asking myself, can I bid jobs and build jobs with this technology, and can I write specifications and enforce specifications with this technology? So this job has really been a blessing to me because it kind of pulls my whole career together. So kind of with that as a background, I wanted to start out by just one slide on the National Center for Asphalt Technology. The test track is actually a satellite operation of NCAT, as everybody calls it, and NCAT is actually over closer to campus here at Auburn University. We were founded in the mid-'80s by a partnership between NAPA's Research and Education Foundation and Auburn University. Our mission is really straightforward. We do innovative, relevant, and implementable research, and then that is geared towards safe and sustainable asphalt pavements, improving the value of asphalt pavements. And it's a very rewarding endeavor, because we don't have an agenda. We just do research to try to make the product better and advance the product. So that's the blessing to all of us. NCAT is a nonprofit research center at Auburn University. So we don't get any like earmarked state dollars or university dollars or anything like that. We execute research. The NCAT pavement test track is the biggest project at NCAT, and it has been the biggest project at NCAT since we broke ground out here in September of 1998. And you can kind of think of it as a nonprofit business. We don't get, as I said, NCAT doesn't get any earmarks. The track doesn't get any earmarks. We sell research to FHWA, to state DOTs, and the private sector partners. Essentially, we sell test sections on the track and execute research with cost recovery for our test sections, with no profit or anything that's built into that. This type of research is really called accelerated pavement testing. We do accelerated damage, meaning that within these 3-year project cycles, the middle 2 years, we compress a design lifetime of pavement damage into that. So for us, that's 10 million equivalent single axle loadings, about 1.5 million miles in 2 years of our fleet operations, using trucks like the ones that you see right there. And we run 5 of these at a time, 5 days a week, from about 5 in the morning to about 11 o'clock at night. And we shut down 1 day a week and do really detailed pavement condition assessments on the track. So I'm telling you all this as background so that you have a feel for the the innovation that I'm going to talk about has been proved on the track. We've supported it with implementation for projects that we've done off the track, and it really all goes back to this accelerated testing that we do here at the facility. Now, these trucks have really high gross vehicle weights because we don't have any bridge spans to collapse, but every individual axle is loaded up to but not beyond the federal legal bridge limit. And we do that so that we can have the safest and most efficient fleet operations as possible in order to compress all this pavement damage. Now, this this business model, we've been, as I said, we've been doing this for over 20 years, and it's really resonated with state DOTs. Half the states in the country fund research here at the test track now, and you see a lot of northern states on this slide, like Michigan and Wisconsin and Minnesota, and that's because in 2015 we engaged in a partnership with the Minnesota Road Research Project, MinRoad, which is a division of Minnesota DOT, so that we've got test sections now that we build up there for cold weather states, so that we can have a thermal cracking focused performance to compare to our southern, more fatigue focused performance here at the NCAT pavement test track. We're very proud of our relationship with the Missouri DOT. Missouri has been a partner here at the facility for about the last 15 years, has been one of our funding partners. We've done a lot of good research for Missouri, and we're excited about continuing that relationship into the future. So for the sake of this presentation, I thought about, Rick, the conversation that you and I had, and sort of the holistic approach to asphalt pavements. So I thought, okay, well, I'm going to touch on each of these areas. I know I've only got 45 minutes, and I'm going to go through this pretty quickly, but we're going to go all the way from mix and materials through thickness design, construction, preservation, maintenance, rehabilitation, and reconstruction. And I think as we discuss innovation in these areas, the advantages of asphalt pavements is really self-evident in all of these areas. And I know all of y'all are professionals, so everybody knows the terminology, but I kind of wanted to have one slide where I explain to you the references that I use, just to make sure that we're all on the same page. So you hear people talk about flexible pavement, that's the same thing as asphalt pavements. Hot liquid asphalt, that's the glue that holds everything together. You got rock, you got sand, and you got filler or dust that you're binding together with the asphalt glue. RAP, of course, that's reclaimed asphalt pavement. RAS, recycled asphalt shingles. You'll hear me several times in the presentation refer to what I call premium mix additives. For example, aramid fibers or highly polymer modified binder or epoxies. That's kind of a general term that we're now beginning to use as we talk about adding materials to our plant mix in order to improve various performance characteristics. And then finally, hot versus warm mix asphalt. I don't even like to distinguish between the two. I really, and I say this as a former agency guy, I think that every mix has a unique temperature that it should be run at, some without the warm mix technologies and some with the warm mix technologies. And I don't think it's a good idea to say, well, everything that we run under 275 is going to be warm mix and everything hotter than that's going to be hot mix, because I've run warm mix at 300 degrees before here because it would have otherwise been a super hot technology because of what we were doing at the time. So I just kind of like to refer to plant mix asphalt, and it kind of encompasses hot mix and warm mix. So I'm gonna go back and touch on all those content areas that we just talked about. And of course, we for the last 30 years we've been working on Super Pave for better mixes, and that Super Pave gave us better aggregate specifications. It gave us performance graded binders with high temperature and mid temperature and low temperature performance with and without aging. And then we got better understanding of mix volumetrics with Super Pave, and those were all tremendous improvements over the mixes that we had been doing up until that time. And of course, kind of the core of that is optimized use of locally available virgin aggregates. And virgin aggregates are becoming more and more scarce in different parts of the country because we are having issues now in some states where there's no new quarries, and the number of active quarries are declining as those sources play out. So we're working to do as much recycling as we can while we at least maintain and ideally improve performance. And we've done research now on the track. We actually know how to do this. We know how to improve, to increase the recycle content at the same time that we improve performance. And we do that through the kind of the targeted use of materials in the various layers in a pavement structure. Part of that equation is the selective use of polymer modified asphalt binders. You know, you at the very bottom of the pavement structure is where fatigue cracks start, and polymers have a place down there. Polymers also have a place near the surface where shear strength, where the shear stresses are higher, and rutting is going to be more of a concern. And then you can, depending on the structure, you can kind of load up the middle of the pavement with higher percentage of recycled material without using polymer modified binder. So it's all kind of a comprehensive view of the pavement structure. And even highly polymer modified binder, commonly referred to as HIMA, that is an important part of the selective use of polymer, because with HIMA binders, you can get the performance of additional structure without the additional structure. So you can make a thinner pavement behave and perform like a thicker pavement, and that's important when you got curb and gutter restrictions or any kind of grade issues like bridges and things like that, or you know, just structural issues where you just can't have enough pavement thickness. Well, you can essentially create thickness type performance using these HIMA binders. We use porous pavements, and sometimes we use them on the surface of roadways as a safety enhancement, but we can also use them in parking lots for stormwater retention, where we're storing stormwater runoff underneath our parking lots, and then that's a big deal when it comes to maximum use of available land resources. Well, and I mentioned the term additives, premium mix additives. We got aramid fibers, or the Kevlar type fibers that we can add to mixes. We got plastics that are going to be the big thing over the next 5 years. Epoxies for really premium mixes. You know, adds cost per ton to the mix, but we're doing research now with epoxies to in the hope of tremendously extending performance. Ground tire rubber has been a big deal. We did ground tire rubber research for Missouri back years ago when we had an SBS polymer shortage, and we know that we can use ground tire rubber in positive ways to build good pavements. And it just kind of comes down to the cost of materials, cost of all the available materials and such. And there's a growing list of mix additives and technologies that we can't imagine today that'll be rolling out 5 years from now. And then finally, performance optimized mix design and construction, otherwise known as balanced mix design, is kind of the next step beyond super pave. So most states had Marshall mixes up through the 70s, and then we got into the 80s, and we kind of evolved into the super pave era. Well, now we're evolving into balanced mix design, where we have a better understanding of the testing resources that are available because of research that's been done at places like the NCAP pavement test track that can create a lot of value for flexible pavements or for asphalt pavements. Probably everybody in this web meeting has heard of this term, balanced mix design. Really all it refers to is, instead of using volumetrics to optimize the proportioning in mixes, we're going to use performance to optimize the proportioning in the mixes. And we do that, one of the easy ways we can do that is with, in this picture, what you see is an old Marshall press with a indirect tensile, split tensile head, load head inserted into it. Well, we can break pills at a medium temperature, 77 degrees Fahrenheit, and a hot temperature here, 122 Fahrenheit. And we can use the cooler samples to assess cracking performance or ductility of the mix. And then we can use the hotter sample to assess the rutting performance of the mix. Now there's you can do a manual analysis of the old plots if you've got one of these devices, but now there's smart jigs you can put inside these machines and do automatic data collection. And the idea with this is that we can kind of balance rutting and cracking and use the relationship between those two performance parameters to optimize the amount of asphalt that we put in our mix. And I like to show this example when I talk about this, because this is actually real data from one of our projects that we did, where the volumetric optimum asphalt content for this 9.5 millimeter en masse mix was 5.6. But if you look at what the performance optimized range of asphalt contents is, it's anywhere between 5.9 and 6.3. So kind of the observation that I make, if you look nationally, I think a lot of our mixes can take 0.5% more asphalt than we're currently putting in them for volumetric optimization, and it can create significantly better performance. And there are a lot of other tests out there. These are the ones that I talk about a lot, because I think it's important now that we can run actual balanced mix design performance tests during production to provide some assurance to the customer that, or the client, whoever it is you're building for, that the mix is gonna perform really well in cracking and in rutting. And this is really simple tests that don't add a lot of cost to your laboratory testing resources. So that brings me to the next area, structural design, or how thick does the pavement need to be? Well, we've got 20 years of experience here at the test track with a big focus on how thick does the pavement need to be. And we do empirical research here, and then also mechanistic research in pavement thickness design. And all empirical, that word just refers to kind of relating everything back to the old Lasho road test and using layer coefficients to do pavement thickness designs using those coefficients. And then when you see the word mechanistic, that just means using stresses and strains and some kind of a transfer function to do a thickness design for a pavement. And I'm an old school guy, so you gotta prove to me that something's better. You know, I'm not gonna get excited about something just because it's a new thing. I wanna see data that convinces me that it's the right thing to do. And we really do need to change the way we design pavement thickness, because you probably heard this concept of perpetual pavements. You know, you design a structure thick enough so that it never cracks from the bottom up, and then we can just do preservation and maintenance on the surface, really shallow type work on the surface, and that pavement can last forever if we do that. You know, a forever resource, which is a huge advantage to asphalt pavements. When we first built the track, the quote perpetual thickness design using the 93 AASHTO design guide, the computer said we needed 2 feet of asphalt. Well, we later learned that using the exact same materials, 9 inches of asphalt was perpetual. So all that extra thickness, everything between 9 and 24 inches, was essentially wasted money. We didn't need that thickness in order to get the same performance of that forever pavement foundation. And then we later found that using innovative materials like the innovative additives, we could go as thin as 5 3/4 inches with highly polymer modified binder and still get perpetual performance, a pavement that will last forever if we just do shallow stuff on the surface. That's an incredible message, and that's with our base and with our subgrade. So you got to make an adjustment to those thickness criteria based on how soft the foundation is that you're working with. But that's a very, very positive message and good information that came from the research that we did here at the track. And kind of at the core of this perpetual concept is optimizing each layer for the intended purpose. And I alluded to this earlier. At the bottom of that lowest layer of asphalt, it needs to be crack resistant so you don't get a bottom up fatigue crack. In the middle of the pavement structure, if you put a stiffer inner layer in that pavement, like you can do with higher percentages of reclaimed and recycled materials, you reduce the deflections, which again, it reduces the possibility of fatigue cracking, bottom up fatigue cracking. And then you put a durable rut resistant surface on that, and you can get a thin pavement that can last forever and do it in a very, very cost effective way. When you do that, you actually, we talk a lot about being able to do thinner pavements. Well, sometimes when you have specialty layers or specialty materials, you need to have a reduced layer coefficient. I mentioned porous pavements. When you have porous pavements, that has to have a reduction, a significant reduction in the layer coefficient because of all the voids that are present in those mixes. And I'll talk about that more in just a minute. But a big part of thickness design is accounting for the benefit that you get from the advanced materials. Going from 24 inches to 9 inches to 5 3/4 inches, how do you quantify that? Well, we have really good guidance that's been developed from the track to help us to do that. And regarding reducing the structural contribution of specific materials, this is a picture from a 100% wrap cold recycle base layer that we put on the track in 2015, and this particular layer, this section is being directly compared to another section that has a conventional hot mix asphalt base, and what we're finding is that the structural contribution of this layer is about 70% of the hot mix equivalent of this layer. And we hope to be able to talk about this a lot more in the near future, because we're starting to see some changes on the track from the control section. But this section on the track with this, and you can see how thick that the pavement is from this slide up ahead of this truck here. This is 100% wrapped cold recycle mix that we produced in our hot mix plant, a double barrel green hot mix plant with the burner completely off. So we didn't have to have any specialty equipment for this. And it doesn't have a whole lot of hot mix on top of it. It's been on the track now for 17 million equivalent single axle loadings, and is one of the best performing sections that we have in this experiment that it's part of. So you can use, if you've got a lot of wrap and you don't have something good that you can do with it in order to optimize the value, like fractionation and running in hot mix, one of the possible uses of it is 100% wrap cold recycle base mix. Now, I wanted to at this point to speak briefly about the additives. How do you account for the additives? And we know what kind of a contribution we can get from the HYMA binder, from the highly polymer modified binder, but we're doing an experiment on the next track that we'll build next summer, where we're going to build really thin pavements, 5-inch thick pavements, and we're going to use this experiment to come up with layer coefficients for the Kevlar fiber mix, or for epoxy mix, or for dry or wet process rubber mix. So we know from past research that with our base and our subgrade, 5 inches of asphalt fails after just a couple of million easels, 20 to 25% of the way through one of our traffic cycles. So this is a very aggressive experiment in order to quantify the structural contribution of these additives, like fibers, plastics, epoxies, rubber, anything else that might come along. And a big part of this is a laboratory validation process that DOTs like MoDOT can use in the future. If somebody comes out with some new type of fiber, this experiment is going to essentially develop and validate a laboratory evaluation process, so you don't have to do big track studies or big field projects for future additives as they roll out. So we're really excited about this experiment, and we'll actually be making the pitch for this to MoDOT when we meet with them to talk about what they want to do on the next track. So moving on to construction, of course, you know, the foundation of good construction is good materials, good designs, good effort by the contractor, and good inspection by somebody to make sure that we hadn't missed anything and everything is going like it has the potential to go. Of course, preparation and repair of supporting layers. All of y'all are professionals, and you know how important this is. We've have done things on the track to quantify the effect that those types of things have. Balanced mix design testing during construction. That's a great tool that we have, where you can provide the owner with, or the purchaser of your product, you can provide them with assurance, hey, this is a great mix, it's not going to crack and it's not going to rut. That's a huge step in the right direction. We learned a lot at the track about the importance of tack interlayers, the glue that holds everything together. You can build a good pavement, but if you don't glue the layers together right, and it it separates, it debonds in the layer interface. Well, now you've got a thicker pavement that's going to behave like a really thin pavement, and it's going to crack, and performance is going to be very bad. So tack quality is very, very important. The importance of achieving good compaction. We have a couple different experiments on the track. One focused on what happens to performance when density goes from a target of 94 all the way down to 88% at different levels in between. And then we've got one that FHWA has funded, what happens when we achieve a higher level of compaction than kind of the typical 94% DOT target. So we've done research. We know that higher levels of density produce better performance, and we're working now to quantify what happens when a DOT makes a decision to accept the job based on lower density. Of course, that's important. You know, I kind of put this presentation together with a focus on roads, but also trying to scope in parking lots and other types of flexible pavement, asphalt pavement structures. You got to keep water out of supporting layers, and density and tack and all those things are really important to keeping water out of the base and the subgrade so you can have good performance. And one of the ways that you can overcome the potential liability of poor performance of tack is to do a full depth rapid rebuild. And this is an exciting study that we're doing right now for South Carolina. And at South Carolina DOT, they have really high traffic truck lanes that are completely failed. And they wanted to know, can we go in there and do 1,000 to 2,000 feet overnight and do a full depth rebuild, doing a really thick layer placement in a single pass? Because the book says you can't do that, but can we do it? And if we do it, what kind of smoothness are we going to get, and what kind of density profile are we going to get? So we did, for this experiment, we did 3 different test sections with between 7 and 8 inches of mat placement, and this was 12.5 millimeter in mass surface mix that we did in a single pass, compacted 8 inches in a single lift, and we cut our cores, did density profiles. We ran this with warm mix technology, and this was just kind of a typical South Carolina DOT type mix, and construction went well. Performance has been outstanding. The only issue with this is smoothness. So South Carolina we knew going into this we were going to have some smoothness issues. So we came back and we diamond ground their section in order to make it smooth enough so that it would be acceptable for an interstate. But then in 2 other sections, we came back and said, okay, well, let's put thin lays on top of that full depth rapid rebuild and see how much smoothness correction we can make. So on the top of this slide is a 4.75 millimeter in mass dense graded mix that was placed a 1/2 inch thick. And then the one on the bottom that you see there is a 475 SMA that was placed 3/4 of an inch thick. And in both of those cases, we were able to bridge over the roughness issues associated with that thick placement. And then the roughness is not reflected in these surface mixes. Now they've been down for 7 million easels, and performance is really good. This is potentially a game changer, and it allows you to think outside the box. So if you've got a project where you have a need to really rebuild quickly, we have this notion in our minds that, okay, we're going to do a 19 millimeter base, and we're going to do maybe a 12.5 millimeter intermediate and a 9.5 millimeter surface, and these are the thickness ranges that we're going to use. Well, you're not bound by that, because we proved in this track, in this research cycle, that the nominal maximum aggregate size, the thickness to nominal maximum aggregate size ratios that the book says we have to use, and you can work outside of those. You're not bound by those factors, and we saw really good density profiles. We actually did 4 of these mats like this, full depth rapid rebuilds, and they've all done really well. But those thin lays now are kind of my turning point to my next topic, which is pavement preservation. And this is sort of the theoretical pavement deterioration curve, pavement condition curve. And with this curve, if we do things early in pavement life, or if we catch deterioration early, then we call those activities preservation. if it, if pavement condition deteriorates further, well, we call that rehabilitation. And then finally, when it gets bad enough, you got to rebuild. We call that reconstruction. Well, there's actually an ASTM standard for pavement condition index ratings that you can kind of overlay onto those bands in that pavement condition curve. And then you can say, okay, well, if my pavement's in really good shape, I can do lightweight stuff to it. But then as it completely deteriorates and fails, there's more effort that I have to do to this. But one of the good things about asphalt pavement is if you've got a customer who is very proactive in taking care of like their parking lot, then there's some very, very low cost things they can do to the surface of that parking lot that will extend pavement life. But at the same time, if you've got a customer that's neglected a parking lot, reconstruction can be done at a relatively low cost compared to other pavement options. So preservation is a great idea, and we promote that because your cost per square yard or cost per lane mile is lowest in the preservation range. But then you still are not going to have to jackhammer out concrete and remove steel and do all the things associated with other pavement choices. Reconstruction can also be done if the owner has not been proactive with pavement preservation. What you really want to do is promote if you're managing a pavement as an asset, either with an agency or out in the private sector with parking lots and connector roads, you want to stay up in the preservation zone, maybe just into the rehab zone, so that you're looking at anything between thin overlays, which for me, a thin overlay is a 3/4 inch or thinner, and all the way up to crack sealing and fog sealing. And when you do that, you can ideally select the options that are going to give you the lowest life cycle cost of ownership of those structures. So in order to really investigate this, we've done research on the track and off the track, and down south and then up north in Minnesota. And we like to do preservation research off the track because that accelerated pavement damage stuff that we do on the track is a really, really harsh, destructive environment. We're really challenging our pavements on the track. So our contractor that we typically work with, they have another plant over on Lee Road 159. It's off the bottom of this slide. You can see their wrap storage yard there off on the left. And this is a dead end access road to the asphalt plant and to a quarry that's located adjacent to the asphalt plant. And as you can see on this road, we've put all different kinds of treatments. We put thin lays and microsurface and chip seals and cape seals and fog sealing and crack sealing and different combinations of those things, so that we can compare distresses at the rate that distresses come back compared to what different levels of condition were these sections in before we place these sections, and we can begin to develop life cycle curves for these treatments. For example, this is a benefit curve for a single layer microsurface, and what you see in these curves is the solid lines are cracking that we map after treatment, and the dashed lines are where would cracking be based on control sections if we had not applied the treatments. So for example, for single layer microsurface, what I've shaded in yellow is the benefit of microsurface when the pavement is in a fair condition before the microsurface is applied. And you can do the same thing to good and to poor and to poor. But what you see here is single layer microsurface does really well. You get approximately the same performance if it's in good to fair condition, but it really takes a nosedive when you go into poor pre-treatment cracking condition prior to the placement of the microsurface. What this means is if your pavement's in poor condition and you put a single layer microsurface down, the cracking is going to come back really quickly, and you're going to get water into the pavement structure, and it's going to kind of go bad on you. Compare that to the thin lay test section on Lee Road 159, and again, we've got a high traffic version in the south, and then low traffic and high traffic up north in Minnesota, where we have all the same treatments. And what you see with the thin lay is significant benefit from the thin lay, regardless of whether the pavement was in good, fair, or poor condition. And you can take that type of cracking reduction information and, for example, go into year 5, look at the cracking reduction at year 5, the gap between the solid and the dash lines for pavements that's in poor, fair, and good condition. And you see that we see very similar performance between a virgin thin lay, a triple chip seal, and a double layer microsurface. So that gives you some information if you're an agency or if you're an owner, what are my options and what kind of life cycle performance do I expect to get, so that you're not doing a comparison between a single layer microsurface and a thin lay, because you're going to get significantly better performance from the thin lay compared to the single micro, but you're going to get very similar performance from a double micro compared to a thin lay. So cities and counties and state agencies can factor in their life cycle costs based on these curves that we're generating from this experiment. Of course, maintenance and rehabilitation is farther down that pavement life cycle curve. So we've done other work on the track with interlayers to determine how does an open graded interlayer compare to a chip seal interlayer, to compare to a dense graded, rich pavement interlayer. Well, we've got another experiment on the track right now that is a lot of people are interested in, because there are 6 different sections, 2 plant mix, 2 chip seal, and 2 geosynthetics. The plant mixes that you see nearest to you, one of them is the one closest to us, is an open graded interlayer. The darker one down past it, that is an Arizona rubber, highly crack resistant interlayer. These 2 are chip seals. This is a coarse fractionated wrap chip seal. That's a virgin number 7 granite chip seal. And then down at the far end, this is a geosynthetic fabric. And then this is a geogrid in combination with a non-woven fabric. So in all 6 of these sections, that there are cracks underneath these sections that we map. They're identical cracks in all 6. So what we're looking for is the recurrence of cracking, so that we can report to Georgia DOT is a sponsor of this, but because Missouri is a partner in the study, they also get the benefit of the results and implementation support. So this is great information, because agencies oftentimes they can't go in and do deep work. They're just going to do mill and inlay work. So if you're going to do mill and inlay work, how can you prevent the recurrence of the cracking in the most cost-effective way possible? If you fall farther down that pavement life deterioration curve, the really nice tool that we have for total asphalt pavement reconstruction is full depth reclamation. And if you're not familiar with this is something that it's really exciting to me, because it's one of the versatility advantages of asphalt pavements. You can go out there and spread cement on top of the existing pavement and run through there with essentially a giant grinding machine that you see in this picture here. And so you spread cement, you grind it up, and you can see the water truck out ahead of this thing. Water is added while it's all blended up, this giant blending machine. This is a Virgin reclaimer that's being used here. And you just come behind it with a motor grader and blade it off. And then this cures for some number of days, like a 3-day cure or a 7-day cure. And then you can come back and it's a very firm foundation that you can build on top of. So this is a great tool that you can use to completely rebuild a totally failed pavement structure, and you can come back and pave directly on top of this FDR foundation. We did test sections in Minnesota this past summer. We actually had 2 FDR test sections. We put 1-inch thin overlays directly on top of those FDR sections, and the results of that study were very, very positive. So that's a really good option. So if you got somebody who has a county or a city with a totally failed roadway, or an owner with a totally failed parking lot, you can do a rapid rebuild using this reclamation process, and then pave asphalt directly on top of it. So to kind of pull all this together into some takeaways, NCAT, as you can see, we're the neutral party between agencies and industry, and we're very blessed because agencies and industry both count on us for objective, reliable, and positive database feedback on these new technologies. The track is ground truth for these perpetual, last forever asphalt roadways. So this is not just a sales pitch. We've got many years of data now to back this approach up. We've got the Minroad partnership, where we've got scoped in cold weather performance. So when you get into the more northern part of the state, Missouri's farther north than we are, you do have some thermal concerns. Well, now we've got the Minroad partnership to support that. And Missouri DOT, as I mentioned, has been a big sponsor in the track for the last 15 years. Hopefully from this presentation, you see we've made a lot of advances in mixing materials and structures and in preservation. The asphalt pavements that we build today are not the same asphalt pavements that we built in the up through the early to mid 1980s. It's a completely different engineered type of a product. It's all about now our best use of available virgin and recycled materials. We want to use as much reclaimed and recycled material as we can. And the idea that you can build any type of pavement and just walk away from it and it be a forever pavement is a myth. Whether it's a rigid pavement or whether it's a flexible pavement, you're going to have to do preservation, you're going to have to do maintenance, and you're going to have to eventually do a rebuild at some point out in the future. But what is the utility cost of that? Asphalt pavements are easy to build, easy to preserve, easy to maintain, and as you saw in this presentation, very easy to rebuild. And that's the reason why I'm really excited about asphalt pavements, because they're safe, they're fast, easy, quickly built, they're affordable, and they're the most sustainable pavement structures that you can possibly build. Well, we host a conference here every 3 years at the end of our research cycles. The next one is scheduled for April the 20th through the 22nd. God willing, we'll have all of our travel restrictions and everything behind us, and life will be back to something that looks a lot like normal by that time. And we would invite y'all down here for this meeting. It's a big implementation focus, and we'll inspect our test sections, and it's just a very, very positive experience. Well, hopefully I ran about as long as you wanted me to run on time there, Rick. Do we have time for questions?
Thanks, Buzz. Looks like if anybody's got any questions, go ahead and feel free to chime in now. It doesn't look like, I'm looking at the chat box here, and it doesn't look like we've got any questions in the chat box, but we've got a few minutes that we can go ahead and open up the lines here. If you want to unmute yourself and ask any questions, feel free.
I'll go ahead and ask one here. Buzz, on your thin lays, I'm guessing they're 4.75 millimeter thin lays. Are you seeing conventional asphalt placed between a 1/2 inch and 3/4 of an inch? That usually just a real fine man sand, and maybe 3/8 or 1/4 inch rock combination?
Our kind of go-to thin lay mix here, it is a 475 mix, but it's 70% stone screenings and 30% hard processed natural sand. And we've kind of used that recipe here as well as in Minnesota, using their materials up there. And what we find with that mix, we run it at a little over 6% asphalt, and it's very predictable from a volumetric point of view, and also from a performance point of view. Compacts really well. It's a nice rich mix, but it's extremely stable. And we've done that mix down to 3/4 of an inch. We did a variation of that mix, slightly different mix design, down to 1/2 an inch, as I mentioned earlier. And we've routinely done 9.5 mixes down to an inch here. We did a lot of those up through 2000 and through the 2009 research cycle. So it's just generally, if the mix is healthy, if it's a good balanced mix design, then you're going to be able to compact it a little bit thinner than what the book says you should be able to compact it.
Are people having any trouble with voids?
In the laboratory or in the mat?
In the mat.
No, not really. And the reason for that is because the asphalt content of those mixes is relatively high. they're going to be between 6 and 7% asphalt, usually in the low 6s. And so because there is so much asphalt in that mix, because of the film coating that's required for that type of gradation, for that small of a dense graded gradation, I've not seen compaction be a problem with that.
Okay, I was more questioning if people are having trouble with low voids being it such a fine mix, you know, where their voids would be, you know, under 3%.
Absolutely not. We've not experienced that. And now in the Marshall era, when we had a more relaxed aggregate quality specifications, yeah, you could run into low void problems, and that would be in the mat and in the laboratory. But in an era where we're dealing with higher quality aggregates and more angular materials, better engineered aggregate blends, we've just not seen it to be a problem.
Okay. Thank you.
Are those mixtures, those 048 mixtures you're running, are those virgin mixtures, or are they allowing any kind of recycle on those?
We've done our 475 mixes. Well, back when we first started doing them was actually 17 years ago, and of course at that time the majority of mixes most everywhere were virgin. So those were virgin mixes. And then when we built that Lee Road 159 preservation study back in 2012, we did virgin mixes and we did 50% fine fractionated wrap mixes, and we did 3% shingle mixes. And what we found was that in both of those mixes, we really needed more asphalt than we had for that was kind of prior to the era for balanced mix design testing. So when the next generation of those 475 mixes, we actually did a balanced mix design iteration using the plant, and we ran different asphalt contents, different combinations of fine wrap and shingles. And we settled on a 475 surface mix that was 11% fine fractionated wrap and 3% post-consumer shingles. And that gave us what we thought was a good balance between cracking performance and rutting performance. And the only issue that we had with that mix, the mat, you know, when you're talking about a 3/4 inch thick mat, you got to be careful with the plant. And when you're running shingles, as probably some of y'all know, you're going to have some plant maintenance that's going to have to be done sometimes on a weekly basis to keep big chunky boogers out of the mat, and because it builds up in the plant and kind of sloughs off and chunks out. So that's really the only issue that we've had with running 11% wrap with 3% shingles, and cracking performance has been very good with that mix. So we've gone full spectrum. We've done virgin, we've done high wrap, and we've kind of settled into a 20% aged binder ratio type mix as a combination between fine fractionated wrap and shingles, post-consumer shingles.
Great. Buzz, we've had a couple other questions come in here. Wanted to get your feedback on. We've got one that talks about that says that many great advances have been shown here. Where can users get guidance or guides for research and implementation? Where can people get more information on that?
Well, as you see on this slide, the NCAT website is ncat.us. The track website is pavetrack.com, but they're interconnected. And at ncat.us, all of our publications, you can download all of our publications from that website. And you can even go to pavetrack.com and you can really dig into the research that we've done at the track and look at specific test sections. But we post a lot of practical implementation focused documents at ncat.us. And then we're always available. We're always available for technical support. You know, if there's some technology that comes up that we've had experience with here at the track, we're very happy to share that experience with anybody who needs it. And that can be someone who's preparing to bid a job with some new specified technology.
Perfect. Thank you. We've got another question about the slides availability. The recording of this webinar will be live on the website and our YouTube channel it's probably by this time tomorrow. But Buzz, can you share the slides with me, and then I will get those added to the presentation.
I'll be happy to do that just as soon as we end the meeting. I'll shoot you an email, Rick.
Perfect. Awesome. A couple more quick questions here. Somebody asked about, I know you mentioned a couple times throughout your presentation that a lot of the research that you were doing is based on, your subgrades there at the track. Do you have any variances in your subgrade, or how do you account for subgrade differences?
That's a great question. And when we're doing controlled experiments where we're looking at differences in asphalt pavement performance, we typically use our standard base and our standard subgrade that goes all the way back to when the track was first built. But we also bring in custom subgrades and custom bases when the state DOTs want us to look at those. So, and we've done that for Missouri. We've done some really soft, high PI Oklahoma subgrades, and we've even got for Mississippi right now on the track, we brought in some really high PI Mississippi clay and looked at lime modification and then cement stabilization of a sand base. So we for each specific state, we build the section the way they want us to build it, but then we step back away from that and look at the body of work and say, okay, now how do all these different subgrades and all these different bases all fit together? So, and you'll find publications that look at the whole body of work at ncat.us.
Great. That's awesome. Thanks, Buzz. Last question here that we have, it talks about tack. And do you tack the chip seal interlays before placing asphalt overlays?
We do. Our practice is, it's more of a fog than it is a tack. You need to be really careful with that, obviously, because you got emulsion that's gluing the chips down, binding the chips, and you don't want to have an excessive amount of asphalt residue that's underneath that asphalt pavement. So I do it, but I shoot a much lower rate. Like I'm an advocate of shooting much higher rates than a lot of people shoot when I'm putting asphalt on top of asphalt. But then when you're paving on top of a chip seal, where many people would say, oh, we don't need to tack that. Well, I'm going to fog it just because I believe that's going to help me out just a little bit, but I'm going to be careful not to overshoot that.
Okay. Well, I think that's it for the questions that have come in. We've had quite a few people chime in just saying, thanks, Buzz. Really appreciate the info. Always learn something new every time I hear you. So lots of kind words. And so with that, we're right here at 12 o'clock. I will say thank you to everyone for joining us, and especially thank you to Buzz for taking the time out of his day down there at Auburn to spend an hour with us and help educate us. And as you see here, Buzz's information is available here on the screen. As I mentioned just a few minutes ago, the recording of this and the slides will be available tomorrow. Also, for those of you on the call, if you need PDH hours from this, those will be sent out probably in the next few days by Brandon or myself. So look forward to seeing those from us, and we will go ahead and close out this meeting. I really appreciate everybody's time today.
Thanks for the opportunity, Rick. Y'all have a blessed day.